Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website, that is www.examsnet.com. This site is a great place for you to practice your entrance exam question papers, because here you will find so many entrance exam question papers along with their detailed PDF solutions, and you must download our app. The link is available in the description box for the better preparation of your exams. So today students, we will be solving Andhra Pradesh Engineering, Agriculture and Pharmacy Combined Entrance Test, that is EAPCET 2023, 18th May, shift 1 question paper. Okay, so students, in this particular video I'll be solving the physics part of the paper. So here we go, starting from the very first question of the physics part, that is question number 81. A certain physical quantity is calculated from the formula pi by 3 a square minus b square hd, where a, b and h are all lengths and d is the density. The physical quantity being calculated is, okay. So this question is from the chapter of units and measurements. Okay. Now, in this question, we are given the formula pi by 3 a square minus b square hd. Let us say this is equals to p. Okay. So according to question, a, b and h are all length. Means a is having dimension of L, b also have the dimension of L, and h it also have the dimension of L. Okay. And d is the density. Means d is having the dimension of density. Means density equals to what? Mass over volume. Okay. So m over volume means L cube, means L minus 3. Okay. So we have to find the physical quantity. Okay. What is this formula as a combination makes? Okay. So this pi by 3 is a constant. A and B are length. So whatever be the dimension of A will be the dimension of B. So this B will now become this L square. Okay. This whole a bracket will become L square into H. H is L and D is density. Density means this M L minus 3. So it will become L cube M L minus 3. So this quantity will become M. So this quantity P is having a dimension formula of mass. It means this P is what? Mass. Okay. So among these four, option C is the correct answer. Now question 82. If the engine of a long train moving with constant acceleration crosses a tree with velocity u, and the last compartment of the train crosses the same tree with velocity v, then the velocity with which the middle compartment crosses the same tree is, okay. So first of all, this question is from the chapter of motion in a straight line. Okay. So according to this question, let us say there is a tree. Okay. There is a tree and a train is passing through this tree. Okay. Train is passing through this tree. Now, when this train moves with a constant acceleration, when it crosses the tree with velocity u, the last compartment of the train crosses the same tree with velocity v. Okay. Initially, it is crossing with the velocity u, and when it comes to the last compartment, it crosses this tree with the velocity of v. Okay. Then the velocity with which the middle compartment passes. Okay, let us say this is first compartment, this is middle one, and this is last one. So when this first one crosses, it crosses with a velocity of u. When this last compartment crosses, it crosses with a velocity of v. We have to find the velocity of this middle compartment. Okay. So for this, here in this particular question, the displacement will be equal to the length of the train. So if the length of the train is L, so the displacement S will be equals to L. Okay. So according to third equation of motion. Using third equation of motion, we can write v square minus u square is equals to 2as. Okay, so from this, a will be equals to v square minus u square over 2s. S means L. Okay, let us say this is equation number 1. Okay, now uh, now the length from one end of the train to its midpoint is L by 2. If the whole train is of length L, so from the length from the end to its midpoint will be L by 2. Okay. So if V1 is the speed, let us say V1 is the speed of the midpoint, means let us say V1 with the speed of the middle compartment, then using the equation V1 square minus U square will be equals to 2A into S. S is what? L by 2. So L by 2. So we can write V1 square minus U square is will equals to A into L. Okay. And from equation 1, the value of A is V square minus U square over 2L. So just put here in the place of A. So V1 square minus U square equals to V square minus U square over 2L into this L. Okay. So solving it, this L cancels. So we get V1 square minus U square equals to V square minus U square over 2. So from this we get V1 square equals to U square plus V square minus U square over 2. Now solving it we get 2U square plus V square minus U square over 2. So this V1 square will become U square plus V square over 2. It means the velocity of the middle compartment when it passes through the tree is under root of V square over 2. So this is our final answer. So among these four options, the option C, that is under root of V square plus U square over 2 is the correct answer. Okay. Now next question 83. A swimmer wants to cross a river which is flowing at a speed V. If the swimmer can swim in still water at speed V, the direction he should swim to cross the river in least time is, okay, this is from the chapter of relativity. So for the least time, if a swimmer wants to cross the river flowing with the speed, river is flowing with the speed V, and the velocity of the swimmer in still water is capital V. Okay, so if it have to cross the river in the least time, so for the least time, the swimmer should swim the cross the river in least time is perpendicular to the flow of the river. Okay, so from among these four options, the option C, that is perpendicular to the flow of the river, is the correct answer. Okay.
So next question is 84. The resultant magnitude of two vectors of same magnitude is equal to the magnitude of either. The angle between the two vectors is. So this question is from the chapter of motion in a plane. So in this question, we are given with two vectors, and according to question, the magnitude of these two vectors are equal. Okay. Let us say the two vectors are vector A and B. And according to question, their resultant is equal. So the resultant means, let us say R is the resultant of two vectors. So the modulus of A plus B equals to modulus of R means their resultant vector. So according to question, this A equals to B equals to R. Okay. Now, we know that the addition formula for any two vectors is equals to A plus B, means modulus of R is equals to under root of A square plus B square plus 2AB cos of theta. Okay, so now squaring both sides, we get R square is equals to A square plus B square plus 2AB cos theta. Okay, since the magnitude of each vector are same, so this will write A square is equals to a square plus a square plus 2ab cos of theta. So this 2a square minus of 2a square plus of this a square, it will be equals to 2a square cos theta. So minus of a square is equals to 2a square cos theta. We can write it as a square plus 2a square cos theta will be equals to 0. So now taking a square common, so 1 plus 2 cos theta will be equals to 0. So this 2 cos theta will be equals to minus of 1. So it will become cos theta will be equals to minus 1 by 2. So theta will be equals to cos inverse minus 1 by 2, means for this the theta will comes out to be 120 degree. This is our final answer. So among these four options, option D is the correct answer. That is 120 degree. Okay. Now next question 85. A bullet of mass 20 gram moving with 500 meter per second is pierced 1 centimeter into a wooden block. Then the retarding force experienced by the bullet is. Okay. So this question is from the chapter of laws of motion. First of all, we'll try to understand this question. Let us say there is a bullet, okay? Its mass is 20 gram, okay? Mass is given as 20 gram and it is moving with a speed of 500 meter per second, okay? Let us say this is a wooden block and this bullet get pierced inside this wooden block, okay? And the distance which is travel inside the wooden block is 1 centimeter, okay? So we have to find the retarding force experienced by the bullet, okay? Since the force is retarding one, okay? Retarding one, so the acceleration will be taken negative, okay, for such type of question. So now m is given as 20 gram, means 0.02 kg, okay? As distance is 1 centimeter, now converted in meter, 10 to the power minus 2 meter, okay? And we are given with speed. U is 500 meter per second. See now, when the bullet travels, so it travels with a speed of 500 meter per second, means the initial speed means U is 500 meter per second and it gets stuck inside this wooden block. So the final velocity means V will be equals to 0. Okay. Now, using third law of motion, we'll write what? V square equals to U square minus 2as, okay? So here final velocity is what? 0. Initial velocity is 500 square minus 2. We have to find this acceleration A into S is 10 to the power minus 2. So solving it, we get A is 500 into 500 over 2 into 10 to the power minus 2. Now solving it, we get A is equals to 12.5 into 10 to the power 6 meter per second square. Okay, let us say this is equation 1. Now we have to find the retarding force. So this retarding force will be equals to F is equals to what? Mass into acceleration. So F will be equals to mass. Mass is what? 0.02 kg into acceleration is what? 12.5 into 10 to the power 6 meter per second square. Now solving it, we get 2.5 into 10 to the power 5 Newton. And we can write it as force will be equals to 250 into 10 to the power 3 Newton. This is our final answer. So the retarding force will be 250 into 10 to the power 10 to the power 3 Newton, means option D is the correct answer. Okay. Now next question 86. A body of mass 10 kg is kept on a rough horizontal surface of coefficient of friction is 0.3. If a horizontal force of 50 Newton is applied on the body, then the acceleration of the body is, okay. So this question is from the chapter of motion in a straight line. Okay, now here we are given with a body of mass 10 kg. Okay, it is kept on a horizontal surface. Let us say this is a horizontal surface and the body of this mass m equals to 10 kg is kept on it, and the coefficient of friction means mu is given as 0.3. If a horizontal force of 50 Newton is applied on the body, okay, 50 Newton force is applied in the body, F will be 50 Newton, then the acceleration of the body, okay. So force 50 Newton is acting in this direction, mu mg is acting in this backward direction, and this mg force is acting in downward direction, and this r force is acting in upward direction. Okay, so if a is the acceleration on the body due to the application of this F equals to 50 Newton force, so F minus mu mg will be equals to what? Mass into acceleration. Okay, so F minus mu is what? 0.3, mass is given as 10 kg and gravity is 10. It is equals to 10 into A, and force is what? 50 Newton. So 50 minus 0.3 into 10 to the power 2, it will be 10A. So solving it, we get A is equals to 20 over 10, means 2 meter per second square. So the acceleration in this question will be 2 meter per second square, means option B is the correct answer. Now next question, 87. According to this question, a toy car of mass 100 gram is moving with velocity of I plus 2j minus 3k meter. Okay, velocity of meter per second it should be. Then the kinetic energy of the car is, okay, we have to find the kinetic energy. So this question is from the chapter of work, energy and power. Energy and power. Okay, now mass is 100 gram. Okay, means 0.1 kg, and velocity of the car is given as ith cap plus 2 j cap minus of 3k cap meter per second. Okay, now the velocity vector will be resultant of all these 1 plus 4 plus 9, so it will be equals to under root of 14 meter per second. We have to find the kinetic energy of the car. The kinetic energy formula is what? Half mv square. So it will be half into mass. Mass is given as 100 gram, means 0.1 kg, into v square, means under root of 14 square. So solving it, we get 1 by 2 into 0.1 into 14. 2 sevens are 14. So the kinetic energy will be 0.7 joule. Okay, so 0.7 is our final answer. So the correct option is C, 0.7 joule. Okay, now next question, 88. The heat energy released by water of mass 2 kg when it is cooled by 10 degrees Celsius is, okay. So this question is from the chapter of thermodynamics. Thermodynamics, okay. Now we have to find the heat energy released in this process. Okay, so we are given with the mass of the water, that is m is equals to 2 kg, and it is cooled by 10 degrees Celsius, means the difference in the temperature is given as 10 degrees Celsius. Okay, so and specific heat is given as 4200 joule per kg per Kelvin. Okay, so heat released by the water will be equals to what? Q is equals to, we know the general formula for is M S delta T. So M is what? 2 kg, S is 4200, and delta T will be 10. So solving it, we get Q is 84000 joule. So our correct answer is option D, that is heat is 84000 joule. Okay, now next question, 89. Which of the following statements regarding center of mass is not true? So this question belongs to center of mass, means the question is from the chapter of system of particles and rotational motion. Okay, system of particles and rotational motion. So it is asking about the center of mass. So the first statement given as, for two particles of equal mass, the center of mass lies exactly between them, midway between them. So this is the true statement, as if there are two masses, let us say this is mass m1 and mass m2. If these are of equal, means it is having mass m, it is also having mass m. So their center of mass will always lies in midway of these two masses. So the first statement is very true. Okay. Second statement, for three nonlinear particles of equal masses, the center of mass coincides with the centroid of the triangle formed by the particle. This is also a very true statement, as if there are three masses, let us say 1, 2, and 3, each of having mass, let us say m, m, m. It is forming just like a triangle, so their center of mass will always lie at this point, okay? Centroid of the triangle. So this statement is also very true. Now, third statement is, when the total external force on the system is zero, the velocity of the center of mass of the system remains constant. This is also a very true statement. Okay, whenever the force becomes zero, so it will have a velocity, and that velocity will become always constant when the force of the system becomes zero. Okay, but the fourth statement is that for two particles of different masses, the center of mass of particle is nearer to the particle of lesser mass. From this statement, for two particle system of different masses kept at a certain distance, the center of mass of the system is always nearest to the greater mass, not towards this lesser mass. So this statement is wrong. So among these four, the option D is the wrong one. Okay. Now, next question, 90. A particle of mass 10 gram is moving towards east with a velocity of 10 meter per second. And another particle of mass 15 gram is moving towards north with a velocity of 5 meter per second. The magnitude of the velocity of center of mass of the system of two particle is. So this question is again from the chapter of system of particles and rotational motion. Okay. Now, according to this question, we are given a particle of mass 10 gram, means m1 is given as 10 gram. It is moving towards east. Okay, let us say this is east direction. So this m1 is moving in this east direction. Okay, with a velocity of 10 meter per second. So this will be equals to 0.01 kg, and another particle of mass 15 gram towards north direction. Let us say this is another particle. This is particle 1, this is particle 2, and it is moving with a, let us say its mass is m2, and it is moving with a velocity of 5 meter per second in the north direction. Okay, so this one is north direction. So m2 is given as what? 15 gram. 15 gram means 0.015 kg. Okay, the magnitude of the velocity of the center of mass of the system of the two particles. Okay, let us say this is plus x direction, moving in positive x direction, and it is moving in positive y direction. Okay, so the v1 is what? 10 meter per second in the I direction, and v2 is what? 5 meter per second in j direction, y direction, na? So their velocity of center of mass will be m1 v1 plus m2 v2 over m1 plus m2. So it will be equals to 0.01 into 10 plus 10 iota cap plus 0.015 into 5 j cap over 0.01 plus 0.015. So it will become VCM, center of mass velocity, 4 iota cap plus 3 j cap meter per second. Okay, let us say this is equation 1. So the magnitude of this will be under root of V4 square plus 3 square. So it comes out to be under root of 16 plus 9 means under root of 25. So VCM will be equals to 5 meter per second. So our correct answer is 5 meter per second. That is option A is the correct answer. Now, next question is 91. The equation of motion of a particle executing simple harmonic motion is given by x equals to 3 sine 60 plus pi by 6, where x is in meters and t is in seconds. The ratio of the potential and kinetic energies of the particle at time t equals to 0 second is. So this question is from the chapter of oscillations. Now, according to this question, we have to find the ratio of potential and kinetic energies, okay? So given the equation of particle performing simple harmonic motion as x is given as 3 sine 60 plus pi by 6, okay? So at t equals to 0 second, so this x will be equals to 3 sine pi by 6. Okay, so it will be equals to 3 sine pi by 6 is what? 1 by 2. So it will be equals to 3 by 2 meter. Let us say this is equation 1. Okay, now the ratio of kinetic energy to potential energy will be equals to, since kinetic energy for such type of simple harmonic motion will be half m omega square, a square minus x square. This is the very general formula, we all know this. And the potential energy is what? Half m omega square into x square. Okay, so dividing the kinetic energy by potential energy, we get 1 by 2 m omega square a square minus x square over 1 by 2 m omega square into x square. Okay, now 1 by 2 m omega square cancels out each other. So kinetic energy over potential energy will be equals to a square minus x square over x square. So it will be equals to a square over x square minus 1. Okay, so it will be equals to 3 square over 3 by 2 whole square minus 1. From equation 1, we have put the value of x, okay? This x equals to 3 by 2 meter. So solving it, we get 9 over 9 over 4 minus 1. So now x will become 4 minus 1. Sorry, this kinetic energy over potential energy will become 4 minus 1 means 3. So we in question we are asked to find the ratio of potential to kinetic. So potential to kinetic will be equals to 1 by 3 means potential energy ratio kinetic energy will be equals to 1 ratio 3. This is our final answer. So the correct option is option D, that is 1 ratio 3. Now next question 92. Two particles execute simple harmonic motion along the same straight line with same amplitude and same frequency. Okay. Now the two particles pass one another when moving in opposite directions, each time at a distance of 1 by root 2 times the amplitude from their common mean position. Okay. The phase difference between the two particle is okay. So this question is again from the chapter of oscillations. So according to question, we have to find the phase difference. Okay. So first of all, let the position of particle 1 is given by x equals to x1 equals to a sine omega t plus phi 1. This is the very common general wave equation for any particle, okay? Position equation. So x1 is equals to a sine omega t plus phi 1, where this a is the amplitude and phi is the initial phase, okay? Initial phase. Now, at t equals to T naught. Let us say at T equals to T naught, x1 is equals to a by root 2 according to question. Na? Let us say this is equation 1 and this is equation 2. Okay, so this a by root 2 will be equals to, from equation 1, a sine omega t naught plus phi 1. At t equals to t naught, x1 equals to a by root 2 according to question. So put in this value of a by root 2 and t equals to t naught, we get a by root 2 equals to a sine omega t naught plus phi 1. So from this a cancels. So omega t naught plus phi 1 will be equals to sine inverse 1 by root 2, and 1 by root 2 is what? 45 degree. So omega t naught plus phi 1 will be equals to 45 degree. Let us say this is equation 3. Okay. Now, the position of particle 2 is given as x2 equals to a sine omega t plus phi 2. Using general equation, this phi 2 is the final phase. Okay. So according to question, when the particle was moving in opposite direction, when it was x2 equals to a by root 2. Okay. So now putting this value of x2, so a by root 2 will be equals to a sine omega t naught plus phi 2. Okay. So this omega t naught plus phi 2 will be equals to 90 plus sine inverse what? 1 by root 2. Okay. So this will be equals to 135 degree. So the phase difference will be the phase difference will be equals to delta phi equals to omega t naught plus phi 2 minus omega t naught plus phi 1. So this will be equals to omega t naught plus phi 2. Now opening the bracket, omega t naught minus of phi 1, this omega t naught cancels. So we get phi 2 minus phi 1. And we know that this is phi 2 and phi 1 is what? 45 degree. This. So putting these values, we get 135 minus of 45. So this phase difference delta phi will be equals to 90 degree, and this is our final answer. So among these four option D, that is 90 degree, is the correct answer. Now next question 93. A satellite is placed in a circular orbit around the Earth at an altitude of 1000 km. The time period of the satellite in minutes is approximately. Okay. So this question is from the chapter of gravitation. Now, according to question, we have to find the time period of the satellite. Okay. So given in the question, the satellite is placed in a circular orbit around the Earth. Let us say this is Earth and the satellite is in this circular orbit at an altitude. Height is given as 1000 km. Okay. So from this H is what? 1000 km. Mass of Earth is ME equals to 6 into 10 to the power 24 kg, and radius of Earth is given as 6.4 into 10 to the power 6 meter. So time period is what? We know that the general formula for time period is T equals to 2 pi r over v. So T will be equals to 2 pi. R will be radius of earth plus this height. This radius of earth plus this height, na? So it will be RE plus H. So RE plus H raised to the power 3 by 2 over under root of GME. Okay. So since we know that on the surface of earth, this gravitation G will be equals to, this G will be equals to G naught GM over RE. So from this, we write GMM over RE into V. Okay. So we write GME over RE plus H whole power 3 by 2. Since we have used the formula, V is equals to under root of GME over RE plus H, and this R is equals to RE plus H. Okay. Forget about this. We have used the formula velocity equals to under root GME over RE plus H, and R will become radius of Earth plus the height, okay, at which the satellite is moving in circular orbit. So solving this, we get T is equals to 2 pi, radius of Earth is 6.4 into 10 to the power 6, plus height is 1 into 10 to the power 6 into 3 by 2 over under root of GME, means 6.67 into 10 to the power 11 into 6.4 into 10 to the power 24. So solving it, we get solving it, we get time is equals to 105 minute. Okay, this is our final answer. So the correct answer is 105 minute. Okay, now next question 94. The sag developed in a bar of length L, breadth B, and thickness D when subjected to a load of W at a center is given by. So this question is from the chapter of mechanical properties of solid, properties of solids. Okay. So there is a direct formula for such type of questions in the theory part also, means in the question you will find the direct formula for this type of question when a bar of length L, breadth B, and thickness D is subjected to a load W at the center, then the sag developed del is, it will be equals to W L cube over 4B dQy, where this Y is the Young's modulus. So this is a direct formula which we use oftenly to solve the numerical questions. Okay. Now next question 95. A swimming pool has depth of 3 meters. The pressure at the bottom of the pool due to water alone is. Okay. So this question is from the chapter of mechanical properties of fluids. Okay. Mechanical properties of fluids. Now, for this question, we are given the depth of the swimming pool having H, means depth as 3 meters. H is 3 meter. Okay. And we have to find the pressure. The density is given as 1000 kg per meter cube. And gravity is 10 meter per second square. Okay. So the formula for pressure will be equals to rho g h. So now putting the values, rho is 1000, gravity is 10, and g h is 3. So solving it, we get 30 into 10 to the power 3 Pascal. Okay. So among these four options, option D is the correct answer, 30 into 10 to the power 3 Pascal. Now next question 96. When an iron rod is heated, the variation of color from dull red to white can be explained by. Okay. So this question is from the chapter of waves. See, this phenomena can be explained with the help of Wien's displacement law. This is why upon hitting the iron piece, first become dull red, then becomes reddish yellow, and finally turns to white hot. Therefore, I conclude that this occurrence is attributed to Wayne's displacement law. Okay. So among these four options, the correct option is option D, that is Wayne's displacement law. As again, if an iron rod is heated, then the color of iron rod will be changed and the temperature will be increased. And this happens due to this Wayne's displacement law only, since lambda n into T equals to what? Constant. That is, when temperature increases continuously, then the wavelength will be changed so that the color of the iron rod will be changed from dull to white. Okay. So this is due to Wayne's displacement law only. Okay. Now next question 97. In a thermodynamic process, if del W and del U are the work done and change in the internal energy of a system respectively, then among these four, we have to find the correct answer. So this question is from the chapter of thermodynamics. Thermodynamics, okay. So according to first law of thermodynamics, okay, from the first law of thermodynamics, del Q is equals to what? Del U plus del W, okay. So for adiabatic process, if for adiabatic process, what? Delta Q is 0. If delta Q is 0, therefore del U plus del W will be equals to 0. It means del U is equals to what? Minus del W. Okay. So for isothermal process, del U is 0. So del from the first law, del Q equals to del U plus del W. Since del U is 0, so this del Q will be equals to del W. Okay. So among these four options, the option D, that is delta U equals to minus W in an adiabatic process, this is the correct answer. Okay. Now the next question is 98. A mixture of gases consists of 16 gram of helium and 16 gram of oxygen. The ratio of specific heats of the mixture is nearly. So this question is from the chapter of kinetic theory. Kinetic theory, okay. Now according to question, we are given with two gases. The first one is helium and the second one is oxygen, okay. The helium consists of 16 gram and the oxygen is of also 16 gram, and we are given the mixture of helium and oxygen gases, and we have to find the ratio of specific heat of the mixture, okay. So for this, mass of helium, we know that 4, and mass of oxygen is what? 32, okay. And helium is 16 and oxygen is also given as 16. So for this, Cv will be equals to N1 Cv1 plus N2 Cv2 over N1 plus N2, okay. Now for helium gas, number of moles, N1 will be equals to mass of helium over molecular mass of helium. So it will be 16, given mass 16 over molecular mass is 4. So it will be 4, okay. So gamma 1 will be equals to 5 by 3. Gamma 1 means gamma is the adiabatic constant. Adiabatic constant. Since helium is a monoatomic gas, for monoatomic gas, the gamma value will be equals to 1 plus 2 over n. Here n is the number of degrees of freedom, and for monoatomic gas, n is 3. So solving it, we get gamma is equals to 1 plus 2 over 3. So gamma will be 5 by 3. Okay. So gamma adiabatic constant for helium, it will be 5 by 3. Now for O2 gas, N2 will be equals to given mass of oxygen over molecular mass of oxygen. So mass given is 16 over molecular mass is 32. So it will be 1 by 2. Okay. And adiabatic constant for this oxygen gas, it will be 7 by 5. How it is 7 by 5? Again, gamma is equals to 1 plus 2 over n. Since O2 is a diatomic gas and the value of n means degree of freedom for a diatomic gas is 5. So solving it, we get gamma is equals to 1 plus 2 over 5. So it will be 7 by 5 means this gamma 2. Okay. Now CV1 for helium gas. For helium gas, CV1 will be equals to R over gamma minus 1. So it will be R over 5 by 3 minus 1. So it will be 3 by 2 R. Okay. Let us say this is equation 1. And for oxygen gas, CV2 will be equals to R over gamma 2 minus 1. That is gamma 1 minus 1. So it will be R over 7 by 5 minus 1. So it will be 5 by 2 R. This is equation 2. Okay. So since we know that CV is what? We have written the value of CV as from this equation N1 CV1 plus N2 CV2 over N1 plus N2. So using it N1 CV1 plus N2 CV2 over N1 plus N2. So solving it, we get 4 into 3 by 2 R plus 1 by 2 into 5 by 2 R over 4 by 1 plus 1 by 2. So just simplifying it, we get CV is equals to 29 over 18 R. Since we know that CV means R over gamma minus 1, so it will be 29 over 18 into R. This R cancels. So solving it, we get gamma minus 1 equals to 18 over 29 means 29 gamma minus 29, it is equals to 18. So solving it, we get gamma is equals to 1.62. So for this mixture of helium and oxygen, we get the value of gamma as 1.62. Option D is the correct answer. Okay. Now next question 99. A gas is expanded from an initial state to a final state along a path that consists of an isothermal expansion doing 40 joule of work, and B, an adiabatic expansion doing W work, C, an isothermal expansion doing 30 joule of work. Okay. If the total change in the internal energy of the gas is minus 20 joule, we have to find the work done by the gas during the adiabatic expansion. Okay. So this question is from the chapter of kinetic theory of gases. Okay. So according to question, first we will use the first law of thermodynamics. Okay. From first law of thermodynamics, we know that del Q is equals to del U plus W, where del Q is a heat change. Okay. Now, and delta U is what? Change in internal energy. Change in internal energy, as we all know. And W is the work done by the gas. Okay. So, given that path A is an isothermal process, according to question, we know that path A is an isothermal process. So, isothermal process means delta U is equals to 0. Okay. Now, for path B means it is an adiabatic expansion doing W work. So, for adiabatic process, delta QB is equals to 0. Okay, since delta QB is equals to 0, so delta QB is equals to delta UB plus WB. Therefore, since this is 0, so delta UB
it will be equals to minus of WB. Okay. And C path is given as isothermal expansion doing 30 joule of work. So for isothermal expansion, delta UC is equals to 0. Okay. So for this, the total change in internal energy will be total change in internal energy. It will be equals to delta U is equals to delta UA plus delta UB plus delta UC. Okay. So minus 20 joule, it will be equals to 0 plus 0 plus delta UB. Okay. Since this will be 0, this will be 0, only this will exist. Okay. So minus of WB will be equals to minus of 20 joule. So WB will be equals to 20 joule. This is our final answer. Okay. So among these four options, option D is the correct answer. Now next question 100. If the pressure of a gas increases by 2% at constant volume, then we have to find its temperature. Okay. So this question is from the chapter of thermodynamics. Now the pressure is increased by 2% at constant volume. Okay. So we know that at constant volume, P is directly proportional to what? Temperature. So thus, if the pressure of a gas increases by 2% at constant volume, then its temperature will also increase by 2%. Means option A is the correct answer. Okay. Now the next question is 101. The mass of 1 mole of a gas is 22.4 into 10 to the power minus 3 kg and its specific heat ratio is 1:6. Okay. The speed of sound in the gas as standard temperature pressure is nearly. Okay. So this question is from the chapter of kinetic theory of gases. Okay. Now we are given the mass of 1 mole of a gas. Okay. Means it is given as 22.4 into 10 to the power minus 3 kg. And gamma specific heat ratio is given as 1.6. Means gamma is given as 1.6. Specific heat ratio means Cp by Cv, ratio of specific heat at constant pressure to specific heat at constant volume. Okay. It is given as 1.6. And we have to find the speed of the sound in the gas. So at standard temperature pressure at STP, pressure is 1.01 into 10 to the power 5 Newton per meter square. This is the standard value of pressure at STP. Okay. And volume at STP is 22.4 liter, means 22.4 into 10 to the power minus 3 meter cube. Okay. So therefore, density of gas at standard temperature pressure, it will be equals to mass of 1 mole of a gas, divided by volume of 1 mole of a gas. Okay. Volume of 1 mole of a gas at standard temperature pressure. So it will be equals to mass is 22.4 into 10 to the power minus 3 as given in the question. 22.4 10 to the power minus 3 and volume is what? 22.4 into 10 to the power minus 3. So it will be equals to 1 kg per meter cube. Let us say this is equation 1. This is density. Okay. Now, speed of the sound will be as asked in the question. Speed of sound, there is a direct formula for this. Gamma into this density
over, gamma into P over this density, okay? So it will be equals to under root of gamma is given as 1.6 and this pressure is 1.01 into 10 to the power 5, okay? 1.01 into 10 to the power 5 over this density, and density comes out to be 1 na. So putting these values we get V is equals to 401.99, that is approximately equals to 402 meter per second. This is our final answer. So the correct answer is option A, okay? Now next question 102. The critical angle for diamond with respect to air is nearly. So this question is from the chapter of ray optics first of all. Now we have to find the critical angle for the diamond, okay? We know that the critical angle is found from this sine formula, this sine IC. It is equals to 1 over mu, where mu is the refractive index. This IC is the critical angle. So we have to find this value of IC, okay? So for diamond, we have to find for diamond, na? For diamond, we know that refractive index is 2.4. This is the standard value of refractive index for diamond, okay? So we have to find the critical angle, means sine IC is equals to 1 over mu, means 1 over 2.4. So IC will be equals to sine inverse 1 over 2.4. So it will be equals to sine inverse 0.42. So solving it, we get the critical angle for diamond is 24.4 degree. Okay, this is our final answer. So the correct option is D. Now next question 103. The angular width of central maximum of diffraction pattern due to a single slit does not depend on, okay. The question is from the chapter of wave optics and it is based on the diffraction pattern. So what happens in a diffraction pattern when a light falls on the slit, it forms a wavefront, and these wavefront forms alternate dark and bright fringes on the screen, okay. These alternate dark and bright fringes all together makes the diffraction pattern, okay. And this source, it should be coherent one. So we have to find the angular width of the central maximum, means the fringe or the band which is formed at the center of this screen. This is having a maximum intensity. So it is called central maximum. We have to find the angular width for this central maximum. So among these four, we have to choose the correct answer, okay? So angular width of central maximum of a diffraction pattern due to a single slit. This is a single slit. Due to a single slit and it's given as 2 theta. It is equals to 2 lambda over d. Means if this is the angle theta, which is which the ray makes with this principal axis, and so this angle theta means this whole angle 2 theta will be equals to 2 lambda over d, okay, where d is the slit width and lambda is the wavelength of the light used. So the angular width does not depends on the distance between the source and the slit, means it does not depends on capital D, where capital D is the distance between this slit and the screen, okay. So the correct option is option A, that is it does not depends on the distance between slit and the source, okay. Now next question 104. The flux coming out from a unit positive charge capped in air is, okay. So this question is from the chapter of electric charges and field. Electric charges and field. See, so the question is asking about the flux. And we know that the electrostatic flux from Gauss law says that the electric flux passing through any closed surface is equals to 1 over epsilon naught times the total charge enclosed by the surface, okay. So according to question, we have to find the flux coming out from a unit positive charge. Means here the value of Q is 1. So phi will be equals to 1 over epsilon naught into 1. So phi will be epsilon naught raised to the power minus 1. So among these four, option D is the correct answer. Okay. Now next question, 105. 3-point charges, 1 coulomb, 2 coulomb, and 3 coulomb are placed at the corners of an equilateral triangle of side 1 meter. The work done to move these charges to the corners of another equilateral triangle of side 0.5 meter is. Okay. So this question is from the chapter of electrostatics. Electrostatics. Okay. According to this question, we are given with an equilateral triangle. Okay. This is an equilateral triangle having side 1 meter, means it is of 1 meter side. Let us say this is A, this is B, and this is C. A is having a charge of 1 coulomb, 2 coulomb, and 3 coulomb. Okay. And we have to find the work done to move these three charges, means 1, 2, and 3 coulomb charges to the corner of another equilateral triangle of side 0.5 meter. 0.5 meter means this equilateral triangle is inside the big equilateral triangle and its side is of 0.5 meter. Okay. So the triangle ABD is formed according to the first configuration given in the question. And let us say this is triangle PQR. Okay. So PQR is formed according to second type of configuration of the charges. Now the required work done will be okay. It will be change in the potential in phase 2 configuration. Okay. It will be change in the potential. So means work done will be equals to potential of PQR minus potential of ABC. So solving it, we get, what is the formula for potential? We know that 1 over 4 pi epsilon naught Q over R. So putting the values 1 over 4 pi epsilon naught, 1 into 2 over 0.5 plus 2 into 3 over 0.5 plus 3 into 1 over 0.5 means this PQR. So this multiply this multiply this multiplies 1 into 2, 2 into 3, 3 into 1. And similarly, minus for this 1 into 2 over 1 because the ABC equilateral triangle is having a side of 1 meter, minus 2 into 3 over 1 minus 3 into 1 over 1. So solving it, we get 1 over epsilon naught means 9 into 10 to the power 9. This is a standard value for this, and solving it, we get 2 over 0.5 plus 6 over 0.5 plus 3 over 0.5 minus 2 over 1 minus 6 over 1 minus 3 over 1. So solving it, we get 9 into 10 to the power 9, 11 over 0.5 minus 11. Okay. So now it will be equals to 99 into 10 to the power 9 joule. So total work done will be 99 into 10 to the power 9 joule. So our correct answer is option C. Okay. Now next question, 106. 4 metal plates, each with surface area A on one side, are placed with separation D as shown in the figure. Okay. We are given with 4 metal plates, this, and this. Okay. And they are each having a surface area A and separation is D. The capacitance between A and B. Okay, we have to find the capacitance between this A and B. So this question is from the chapter of electrostatic potential and capacitance. Okay. Now, since we have to find the capacitance between A and B, And we know that the capacitance between any two adjacent plates, the formula for capacitance is what? C equals to epsilon naught A over D. This is the basic formula for finding the capacitance between any two parallel plates, okay? So these four parallel plates will make three capacitance. Mean if we draw it like this, 1, 2, 3, 4. So these, let us say this is A, B, C, and D. So these four plates are making three capacitance, mean 1, 2, and 3. Okay. Now we can draw the equivalent for this as let us say first it will make a capacitance between B and A. Then it will make a capacitance between D and C, okay? And so on. Let us say this is A, this is B, and now it will make a capacitor between B and C, okay? So now this is the simplified form of this circuit. So solving this circuit, we will get a desired answer, okay? Since this BA and DC are connected in series, BA and DC capacitors are connected in series. So for series, we know that 1 over C equivalent equals to 1 over C1 plus 1 over C2. Since each capacitor is having a capacitance C, so we get 1 over C plus 1 over C. It will be 2 over C. So C equivalent for this BA and DC, it will be equals to C by 2. Let us say this is equation 1. And for BC, it is C. And this, their C equivalent and this BC, these are connected in parallel. So for parallel, we know that the capacitance C is equals to C1 plus C2. So just add them. So we get this C by 2 plus this C, okay? This C. So solving it, we get 3C by 2. So the net capacitance will be equals to 3 by 2 into C. C means epsilon naught A over D. So this is our final answer, means option A. That is, sorry, option D. That is 3 epsilon naught A over 2D is our correct answer. Okay. Now next question 107. In order to quadruple the resistance of a uniform wire, a part of it is uniformly stressed so that the final length of the wire becomes 1.5 times the original length. The frictional length of the stretched part 8. Okay. So this question is from the chapter of current electricity. Current electricity. Okay. Now it is saying that in order to quadruple the resistance of a uniform wire, let us say this is a uniform wire and we have to quadruple its resistance. Let us say its resistance is R, okay? If we quadruple the resistance, a part of this is uniformly stretched so that the final length of the wire becomes 1.5 times the original length, okay? So let capital L be the original length of the wire and let small l be the length stretched, okay? This capital L will be the original length and this small l is the length stretched. Okay. Now 4R, it is saying na ki it is being quadruple. So 4R will be equals to rho L minus L over A. Since we know that R equals to rho L over A, and L minus L means the original length minus the length that is stretched over A. So it plus rho over this 0.5 L plus small l over A dash. Okay. Now, this A dash is here, the A dash is what? L into A over 0.5 L plus L. Okay. So solving it, we get 4. This R means rho L over A. It will be equals to rho L minus L over A
plus rho 0.5 L plus L, and putting this value of A dash, we get LA into this 0.5 means it's a square. Okay. So solving it, we get rho over A, rho over A, rho over A cancels. So 4L will be equals to L minus L plus 1 over 4 into L square over L plus L square over L plus LL over L. So again simplifying it, this is just a simplified form of this equation and nothing very difficult. Okay. So solving it, we get L over L equals to 1 over 8. This is our final answer. So 1 over 8 means fractional length over the stretch part means capital L over L is what? 1 over 8 means option B is the correct answer. Now next question. In the circuit, the value of the current I is, okay. So this question is again from the chapter of current electricity, okay. We will solve this question using Kirchhoff's voltage law, means KVL loop. So let us draw it again. Like this is what? 12 volt, okay. And it's of 3 ohm. Current is flowing in this direction, okay. And this is of 6 volt and 6 ohm, and current is flowing in this direction. This is current I, this is also current I, and here is a resistance of 4 ohm, okay. Let us say I current is flowing in this direction. So this I current divides into 2 branches now. Let us say this is I1 and this is I2, okay. Let us say this is A, this is B, C, D. Let us say this is E and this is F, okay. Now using Kirchhoff's voltage law in loop A, B, C, D, A. Okay, if we use the Kirchhoff's voltage law, means let us say this is like this. So we get 12 minus of 3I1 plus 6 I2 will be equals to 0. Okay. So minus of I1 plus 2I2, it will be equals to minus of 6. So I1 minus 2I2, it will be equals to 6. Now 2I1 plus 4I2, multiplying this whole equation with 2. Okay, multiplying it with 2, we get 4I2 equals to 12. Let us say this is equation 1. Okay. Now applying KVL law in loop. What is this? D, C, F, E, and D. Okay. D, C, F, E, and D. So from this, we can write from D, C, F, E, and D, we can write this minus of 6 I2 minus of 4 into I. This is current I, okay. So it will be equals to 0, okay. So writing it, we get minus of 6 I2 minus of 4I will be equals to 0. So minus of 6 I2 minus of 4, and I is what? I1 plus I2 equals to 0. So minus of 4I1 minus of 10I2 is equals to 6, means 2I1 plus 5I2 equals to minus of 3. Let us say this is equation second, okay. Now subtracting this equation 1 from equation second. Subtracting equation 1 from second, we get equation, let us say this is 2i1 plus 5i2 equals to -3, and this is 2i1 plus 4i2 equals to 12. 2i1 plus 4i2 equals to 12. So subtracting it means minus, minus, minus. So it cancels out. This will be 4. It is minus or plus? Plus 4i2. Sorry, this is minus 4i2, na? So this minus will become plus. So 5 plus 4, 9i2 will be equals to minus of 15. So I2 will be equals to minus of 15 over 9. So it will be equals to minus 5 over 3 ampere. So I2 comes out to be minus 5 by 3 ampere. So just putting the value of this I2 in, let us say, equation second. So we get 2i1 plus 5, I2 means minus 15 over 9 is equals to minus of 3. So solving it, we get 2i1 is equals to minus of 3 plus 25 over 3. It will be equals to 16. Oh, sorry. It is 5. 5 over 3. Okay, 15 over 9 means 5 over 3 only. Okay, so it will be 16 over 3. So I1 is equals to 8 by 3 ampere. So value of I2 is minus 5 by 3 ampere and I1 is 8 by 3 ampere. So total current in the circuit I is equals to I1 plus I2 means this 8 by 3, sorry, means this 8 by 3 minus of 5 by 3. It will be equals to 3 over 3 means 1 ampere. So the total current in the circuit is 1 ampere current. So option A is the correct answer. Okay. Now next question 109. For parallel conductors and steady currents, the results in accordance with Newton's third law are. So this question is from the chapter of moving charges and magnetism. Moving charges and magnetism. Okay. So the question is asking about the Newton's third law, means for parallel conductor and steady currents, the results in according with Newton's third law are, okay. So for parallel conductors, we know that for parallel conductors, let us say these two conductors are in parallel combination, and steady current, the results in accordance with Newton's third law are Biot-Savart law always. Okay, these are in Biot-Savart law and Lorentz law force. So among these four, option A is the correct answer. Okay. Now next question 110. Considered a tightly wound 100-ton coil of radius 10 centimeter carrying a current of 2 ampere. The magnitude of the magnetic field at the center of the coil is, okay. So this question is from the chapter of magnetism and matter. So according to question, there is a tightly wound 100-ton coil whose radius is 10 centimeter, means given capital N, let us say number of turns is 100. R is given as 10 centimeter, means 0.1 meter, and current is given as 2 ampere current. The magnitude of magnetic field at the center of the coil. We know that let us say this is the coil, wounded coil, and we know that for a solenoid, always the magnetic field at the center of this solenoid coil is equals to magnetic field is mu naught and I over 2. Okay, so for this, putting the value of all these parameters in this, we will get a desired answer. Mu naught is what? 4 pi into 10 to the power minus 7. Capital N is 100. Current is given as 2 ampere over, sorry, this is 2R, sorry.
2 into r is 0.1 meter. So solving it, we get magnetic field is equals to 4 pi into 10 to the power minus 4. So it will be equals to 4 into 3.14 into 10 to the power minus 4, means it will be 12.56 into 10 to the power minus 4 Tesla. And this is our final answer. So among these four options, the option C, that is 12.56 into 10 to the power minus 4 Tesla, is the correct answer. Now, next question is 111. If B is magnetic field and Q is the charge, then the following represents the Gauss law of magnetism. Okay. So this question is from the chapter of electromagnetic induction. Electromagnetic induction. Okay. The question is asking about the Gauss law of magnetism. Okay. The Gauss law of magnetism, it means that this Gauss law of magnetism states that the magnetic flux phi b is equals to surface integral of magnetic field is equals to 0, means the closed surface integral of magnetic field around any closed path, the total magnetic flux passing through any closed path, the magnetic field lines passing through any closed path is equals to 0. This statement also state that a monopole does not exist. Okay, monopole does not exist means always in a magnet there will be always one north pole and one south pole. Single north pole or single south pole magnet does not exist. So this Gauss law of magnetism states that monopole does not exist. It means surface integral of B dot ds is equals to 0. So option A is the correct answer. Okay. Now next question. A circular coil of radius 10 centimeter and resistance of 2 ohm is placed with its plane perpendicular to horizontal component of the Earth's magnetic field. It is rotated about its vertical diameter through 180 degree in 0.25 second. If the magnitude of the induced EMF is this, then we have to find the number of turns of the coil. Okay. Again, this question is from the chapter of electromagnetic induction. Okay. Now, according to question, we are given a circular coil of radius r equals to 10 centimeter. 10 centimeter means 0.1 meter, and resistance R is given as 2 ohm. Okay. And it is placed in a magnetic field. So this magnetic field B is given as 3 into 10 to the power minus 5 Tesla. Okay. This. And delta t time is given as 0.25 second, and the induced EMF E, it is given as 3.8 into 10 to the power minus 3 volt. We have to find the number of turns of the coil. We know that the induced EMF E, it is equals to minus number of turns into del phi over del t, means we can also write it as minus n delta phi over delta t. Okay. And this magnetic flux phi is equals to B dot A, means magnetic field into this area. And this is dot product. So we know that for dot product, we always use cos theta term. So in place of del phi, we can also write BA cos theta. Okay. So this EMF now becomes minus N BHA cos theta over dt times, means delta t times. Now we know that we are given with two angles, theta 1 and theta 2. Since it is rotating with an angle 180 degree, na? So we are given with two angles. So we can write EMF as minus n BHA cos theta 2 minus BHA cos theta 1. See, at first means at initially theta 1, we are given angle 0 degree, And after that, theta 2 is given as 180 degree according to question. So just put the values here and we will get our desired answer. So EMF now becomes minus of n, taking BHA common. So we can write cos theta 2 minus cos theta 1 over delta T. Okay. Now this will become minus of n BHA. Magnetic field is given as 3 into 10 to the power minus 5 and area is pi r square. So we can write minus of n into 3 into 10 to the power minus 5 into area means pi into r square 0.1 whole square into cos theta 1 and cos theta 2 minus cos theta 1 means cos of 180 degree minus cos 0 degree over delta t. Delta t is what? 0.25 second. So solve it and EMF is given as EMF is 3.8 into 10 to the power minus 3. So just write here 3.8 into 10 to the power minus 3 into this 0.25. It will be equals to 3 pi n into 10 to the power minus 5 then into 0.1 square cos 180 means minus 1 minus cos 0 means 1. So solving it we get n equals to 504.25 means n is equals to 504 means number of turns in the coil is 504. So among these four options, option A is the correct answer. Okay. Now next question 113. An inductor of inductance L, a capacitor of capacitance C and a resistor of resistance R are connected in series to an AC source. The quality factor of the circuit is okay. So this question is from the chapter of alternating current. Okay. So we are given an inductor of inductance L, a capacitor of capacitance C, a resistor of resistance R. These are connected to an AC source. Okay. Now we have to find the quality factor. We know that in such cases in LCR series circuit, the quality factor Q formula is equals to impedance over resistance R. Okay. So it will be equals to impedance is what? Omega into L over R. So it will be equals to omega. We know that 1 over under root of LC into L over R. So it will be equals to we can write it as 1 over LC into L square over R square. Okay. So this Q quality factors now becomes under root of L over CR square. Okay. So Q is equals to under root of L CR square means option A is the correct answer. Now next question 114. If E naught, B naught are the magnitudes of electric and magnetic field respectively of an electromagnetic wave in vacuum, then among the following the correct relation is okay. So this question is from the chapter of electromagnetic waves. Okay. Now electric field magnitude is given as E naught, magnetic field magnitude is given as B naught. Okay. So we know that there is a famous relation between electric field and magnetic field, that is E naught is equals to B naught into C. And we know that C is equals to 1 over under root of mu naught into epsilon naught. So just put the value of C over here, B naught into C over under root of mu naught into epsilon naught. So this E naught into epsilon naught will be equals to this, okay, not C, this B naught over under root of mu naught. So from this, we say that option C is the correct answer. That is E naught root of epsilon naught equals to B naught over root of mu naught, okay? Where epsilon naught is the permittivity of free space and mu naught is the permeability of the free space, okay? Its value is 4 pi into 10 to the power minus 7 and epsilon naught value is 8.854 into 10 to the power minus 12, okay? Now next question 115. Photoelectrons are emitted with maximum velocity v with when light of frequency 3f incident on a photosensitive material or work function 2 hf, okay? If the frequency of the incident light is 4.25 f, the maximum velocity of the emitted photoelectron is, where this h is the Planck's constant, okay? So this question is from the chapter of dual nature of radiation and matter, okay? Radiation and matter. Now the question is about the phenomena, and that phenomenon is photoelectric effect, okay? What happens in a photoelectric effect? Whenever a light means photon having wavelength lambda, let us say there is a photon gamma and it is having a wavelength lambda and it is incident on the surface of the metal, then some electrons are ejected from the surface of the metal and these electrons are called photoelectrons, okay? And for such type of phenomena, there is one famous equation, that is maximum kinetic energy of these photoelectrons equals to initial kinetic energy minus phi. This phi is called the wave function, okay? Now, according to question, we are given that the photoelectrons, these are emitted with a maximum velocity v, okay? Photoelectrons are emitted with a velocity v, and when light of frequency 3f incidents on photosensitive material. So this light, this photon is of frequency 3f, okay? And the work function means phi. Phi is given as 2hf. Then if the frequency of incident light is this, then we have to find the maximum velocity, okay? Since kinetic energy means V max is equals to given as V into phi naught, it will be equals to 2hf, okay? So this K maximum will be equals to h f dash minus phi naught. This kinetic energy maximum equals to Sc over lambda minus phi. This Sc over lambda is what we can write it as hf now. So we write K maximum equals to hf dash minus phi naught, okay? So this f dash is equals to what? 3f. So we can write it here h into 3f minus of phi naught. Phi is given as 2hf, okay? So we can write this kinetic energy is what? Half mv square. So this half mv square is equals to 3hf minus 2hf, means hf. Let us say this is equation 1, okay? Now, according to next condition, if the frequency of incident light is 4.25 f, now the frequency is 4.25 f, means for second condition, kinetic energy max will be equals to hf dash minus phi naught. Now for second condition, we write h into f is what? 4.25 f minus phi naught is what? Work function 2hf. So it will be equals to 2.25 hf. Let us say this is half m v1 square, okay? The first one is half mv square, second one is half m v1 square. So let us say this is equation second. Now dividing equation 1 by second. Dividing equation 1 by second. So we get what? Half mv square is equals to, from equation 1 it is equals to hf. So half mv square equals to hf over this half mv1 square equals to 2.25 hf. So this hf cancel, half m cancels. So we get v square over v1 square is equals to 1 over 2.25 means V1 equals to V under root of 2.25. It will be equals to V 1.5 means V1 will be equals to 1.5 V. So our correct answer is option C. Okay. Now next question 116. If mu is the magnetic moment of an electron revolving around hydrogen nucleus in an orbit of principal quantum number n, then okay. So this question is from the chapter of atoms and nuclei. Since the question is asking about the principal quantum number n. Okay, the question is asking about the relation part. Okay, since we know that the magnetic moment mu of the revolving electron around the nucleus is equals to E by 2m into L. We all know that whenever there is a nucleus and the electron revolves around the nucleus, so this electron is doing orbital motion. So for orbital motion, this mu magnetic moment, orbital magnetic moment is equals to E into 1 by 2m into L. So this is a very standard formula. Okay, and according to Bohr's law said that the angular momentum of any electron revolving in an orbit around the nucleus, its angular momentum will be equals to integral multiple of nh over 2 pi. This is the famous Bohr's postulate. Let us say this is equation 1, this is equation 2. So from first and second, just put the value of this angular momentum from equation 2 in equation 1. We get magnetic moment mu is equals to E over 2m into nh over 2 pi. So it will be equals to NEH over 4 pi m. Okay. This mu now becomes NEH over 4 pi m. This EH over 4 pi m, we can write it as mu b, where mu b is called Bohr's magnetron. Okay. Bohr's magnetron. Okay. So from this relation, the correct option is NEH over 4 pi m means mu is directly proportional to n. Okay. So option B is the correct answer. Now next question 117. A radioactive decay forms an isotope of the original nucleus with the emission of the following particles. Okay. This question is again from the chapter of atoms and nuclei. Now, the question is asking about the radioactive decay. Forms an isotope of the original nucleus with emission of the following. Okay. So from this, we know that on emission of an alpha particle, whenever an alpha particle emits from a radioactive nuclei, atomic number decreases by 2 units, and on emission of beta particle, the atomic number increases by 1 unit. Okay, whenever an alpha particle emits from a radioactive nuclei, its atomic number, let us say this is XZA for an alpha particle, let us say. For an alpha particle, the atomic number is decreased by 2 units, means whenever the product is formed, we get Z minus 2. Okay, and for a beta particle, the atomic number increases by 1 unit, means this ZXA, where Z is the atomic number, A is the mass number, this becomes Z plus 1. Okay, this is Y is the product. So thus a radioactive decay forms an isotope of original nucleus with emission of 1 alpha particle and 2 beta particle. Okay, so the correct option is we get 1 alpha particle and 2 beta particle. So the correct option is option C, that is 1 alpha particle and 2 beta particles. Okay. Now next question 118. A reverse bias Zener diode when operated in breakdown region works as. Okay. So this question is from the chapter of semiconductor. Semiconductor. conductor. Okay, so it is asking about the Zener diode breakdown reason. So Zener diode breakdown reason, something seems to be like this. This is the breakdown reason. Okay, this is the breakdown reason for a Zener diode. Okay, so more breakdown reason, more good will be the Zener diode. Okay, so a Zener diode is heavily doped p-n junction diode, and it always operates in reverse breakdown region as a voltage regulator. Okay, so our correct answer is option C. Now next question 119. The current amplification factor and the collector current in a CE transistor collector emitter transistor circuit are 100 and 2.2 milliampere respectively. Okay, we have to find the base current. This is a very simple question. So this question is also from the chapter of semiconductor. Just we have to apply one simple formula for it. We are given beta amplification factor. Beta means 100 and collector current IC given as 2.2 milliampere. 2.2 milliampere means 2.2 into 10 to the power minus 3 ampere, and it is asking about the base current. So there is a very famous relation for this. We know that collector current is equals to beta into IB, means collector current equals to amplification factor beta into base current. Okay, so this base current IB will be equals to IC over beta. Just put the value 2.2 into 10 to the power minus 3 over 100. So solving it, we get 2.2 into 10 to the power minus 5 ampere, means 2.2 in, sorry, 22 into 10 to the power minus 6 ampere. So we can write it as 22 microampere. So base current for this relation will be 22 microampere. So option B is the correct answer. Okay. Now next question 120. Digital signal. Okay, we have to find the correct answer. Digital signal is represented by a sine wave, or utilizes binary code system, or it is represented by a cosine wave, or utilizes a hexadecimal code. Okay, so we know that all the binary, all the digital signal, all the digital signal and systems always use what? Binary code system means 0 1. They always use binary code system. So the correct answer is option B.